We know if we see a positive integer how to find the equivalent decimal. So if I give you 0, 1, 0, 1, what is the equivalent decimal of that? You will take the powers of 2 that are represented in that representation. Again, it is 0, 1, 0, 1, and you will find what is the equivalent number. So it will be 2 to the power of 2 plus 2 to the power of 0, so it will be the number 5. It is pretty straightforward. Now, if I give you a number, a negative number, that is represented using the 2's complement, how will you be able to find the equivalent decimal? Say, for example, you have the number 1011. What should you do if I tell you that this is a number represented with 2's complement? One way to find the equivalent decimal is to do exactly the opposite steps as we would do in order to produce a number. So we take the binary representation, we subtract 1, and then we flip all the bits. So we find the positive integer, and from the positive integer we find out which positive integer it is. We see which powers of 2 are there, and we just put the sign minus in front of it. This is one way to do it. Another way to do it is described in this slide. You have the representation 1011. We know that this is going to be a negative number. We just said that when the leading bit is 1, then we're talking about a negative number. So here's what we're going to do. We're going to have the sign minus for the leading power of 2, which in this example will be 2 to the power of 3. So we will put minus at the 2 to the power of 3 number, and then we will do exactly the same as we're doing when we're finding out the value of any other positive number, binary number. So we will add all the powers of 2 that come after that, which in this example is 2 to the power of 1 plus 2 to the power of 0. If we make this addition, we will come up with minus 5, which is actually the representation of the decimal representation equivalent to the binary representation. The discussion we just had concerned how we can find the decimal representation if we are given the binary representation, especially when we're talking about negative numbers. Now we're going to do the opposite. We're going to convert the decimal representation into the binary representation. And we have done that before. The difference is that we did it for a positive integer. Now we're going to do it for a negative integer. Suppose, therefore, that you want to find what is the binary representation, 2's complement binary representation, of minus 42, and the number of bits we want to use is 8. How are we going to start? We always start with the equivalent, the corresponding positive integer. So we will take the positive integer, which is 42, and find out the binary representation. We have done that in the past. We have actually done it for this particular number. So if you are not sure why the binary number you see on your slide is the answer, go back to the video that we discussed how to find the representation for that. Then we are going to do a very important step, which is often overlooked. How many bits do we need in order to express 42? We need 6. However, we said that we want to use 8 bits. We're going to assume that the number of bits available to us are 8. So what is important, what is necessary to do is go and fill in the 2 bits, the 2 most significant bits, with zeros. This is exactly the same number since we are filling in with zeros. It is a very important step because of the steps that are going to follow. What do we do when we want to find the 2's complement? We're going to first flip all of the bits, and this is why it was very important to fill to 8 bits. Otherwise, we wouldn't have those 2 leading zeros that became the 2 leading ones. And our representation would end up being wrong. So we flip every digit, and then, since we don't want the ones complement, but we want the twos complement, we're going to add the number 1 to the result that we just achieved. So we added 1, and here is the number that actually is the binary representation we are looking for. If you would like to test and to verify more examples, I invite you to go and look at the website that is on your slide. It will help you experimenting.